this video is about section 13.1, starting to look at conic sections. And the only two we're going to look at are parabolas or circles. So by the end of this video, you should understand what the equation of a parabola looks like, how to find its vertex, and whether it's an up or down, or left or right parabola. And then circles, what the equation of a circle looks like in standard form and how to put things into standard form. So basically, curves that are formed by cross sections of cones. If you take a cone and you take a plane and you just slice through it at some angle, then you'll get different kinds of shapes depending on what angle that plane went through. And they all have ax squared plus by squared plus cxy plus dx plus ey plus f equals 0 as their equations. Now, what these constants look like determine which shape it'll be. So if b, c, and e are all 0, we have a parabola. That's the one that you should recognize, okay? So it just depends on which of those terms are there and which of them are not because the coefficient was 0. So imagine a cone, and we have these two cones up and down because we have to include the hyperbola here. So a parabola is when you take a cone at an angle through just a plane at an angle through just one cone. You get a circle if you take and if you don't go through it twice. So you go from the top down to one side. Okay. A circle is a plane that goes straight across, parallel to the base. An ellipse is what you get if you take that plane and you go through both sides, not the top or bottom or whichever it is, but both sides at an angle. Then you'll get an ellipse. And if you take a plane and you go through one side of both cones, you get what we call a parabola, a hyperbola. Hyperbola. So parabola, circle, ellipse, and hyperbola are our four conic sections. Today we are just concentrating on the parabola and the circle, and for this class these are the only ones we will do. Okay, so the conic section that's a parabola, I'm going to go through this kind of quickly because we've just covered this and this should all be fresh in your mind. But there are a lot of applications for parabolas in physics, electricity, mechanics, and optics. Okay, so we know what the equation of a parabola that's a vertical parabola, opening upward or downward, is. If we just flip the x's and the y's, we'll get one that opens left or right. This term axis of symmetry, if you take the vertex of an up or down parabola and draw a straight line, vertical line down through that point, that's what's called the axis of symmetry. And it's called that because the parabola is absolutely symmetrical on the two sides of that line. Okay? When you turn it on its side so it opens left or right, then it's going to have an axis of symmetry that's a horizontal line, but again, right through the vertex. So we know how to graph this. We complete the square to find the vertex. There's all the work of that. You can pause the video if you want to look through that work and make sure that makes sense to you, but we've just done this, so I'm not going to go through all that. And that gives us a vertex of 3, 1. Remember, the vertex is HK. So if we take the vertex and then we put some points on either side of it, we end up looking like this. It looks extremely symmetrical just in the dots, and we will connect them. This axis of symmetry I'm talking about is right through 3. So it's x equals 3 is the axis of symmetry here. Because there's a positive coefficient for x squared, the graph opens upward. It's an up parabola. The other way to do the vertex of a parabola, we all agreed was a little bit more difficult, but what you would do is the x-coordinate of it is minus b over 2a, and you can plug that in, and you can get the y-coordinate. Either way you want to do it is fine with me. I really don't care. Okay, now if we flip it around and we put y where, oh, I'm sorry, we're still with x where it was. Okay, so if we want to graph this equation, either we complete the square to find the equation with h and k in it, or we find the vertex by using minus b over 2a for the x-coordinate and finding the y-coordinate. We choose values on each side, compute the corresponding y values, and we know whether it opens up or down. Now if we flip them, there's a slide ahead of myself, we're going to have horizontal parabolas. They open to the right towards the positive side, just like the up is towards the positive side. If they have a positive A, and they open the other way if they have a negative A. And they have axes of symmetry that are y equals lines. So if we try to graph this one, we'll complete the square to find the vertex. And again, it's exactly the same, except we just have switched, so we have y over with the square in it. Okay, so again, I'm just going to let you look through this if you need to. You can pause the video, look through this, make sure you get the same numbers and understand where all that came from. Ask me questions if you need to in class. When we find that the vertex is at 2, 3. Now, this is the place where you need to be careful, because this time the vertex is going to be KH, not HK. Okay, and that's because we've swapped our variables. So the variable that's squared gets the h as its coordinate, but that's y, so that's why it's gone in the second coordinate. This parabola is going to open left because it's got a negative, it has a negative coefficient on the y squared term. We plot some points on either side. We figure out that this is what it looks like. The axis of symmetry is here at y equals 3. So again, either complete the square to find this equivalent equation, or use minus b over 2a to find the y coordinate and substitute to find the x coordinate. Find values that are above and below the vertex, compute the corresponding x values. You know which way it opens based on the coefficient of the squared term, and you put it in there. Sorry, you put it in there like that. That is how you do it. Now, after you do a couple of these, feel free to do it in your calculator. Okay? Another conic section is called a circle. We all know what a circle is, but we define a circle as a set of points in a plane that are a fixed distance from a fixed point. So imagine if you put a nail in a piece of wood and you take a string of a certain length and put a pencil at the end of it, and then keep that piece of string tight, and draw all the way around, and that's how you get a circle. The fixed point is the center, and we call it HK. And the distance that each of those, that circle is from that center is the radius. So that should all make sense to you because you know what a circle is and you've been dealing with them for a while, but it's said in a little bit different language. So you might need to pause and kind of look at the language a little bit. Make sure that those words get in your vocabulary list or in your vocabulary note card so you remember how it's said and how we're using the language right now. So the distance formula is going to tell us that if the radius is the distance from the center, HK, to any xy on the circle, then we know using distance formula that the radius is this. Okay, we're using h and k is our x2, y2, and x and y is our x1, y1. Okay? And then if we square both sides of that, we get what is called the standard form of the equation of a circle. Okay, x minus the x-coordinate of the center squared plus y minus the y-coordinate of the center squared equals the radius squared. Oops, what have I done? Sorry. So again, here is the equation of a circle in standard form. Make sure you have this written down. So you want to pause the video right now and get it written down just like that. Okay. So notice that if h and k are 0, then the center is the origin because it's the point 0, 0. If it's not, then you're going to move that circle a certain number of units horizontally and a certain number of units vertically. And those are given by h and k. And that'll get you to where you are on the circle. So we're going to find the equation of a circle with a center of 1, 7, and a radius of 4. So we're going to use the standard form, and we're just going to put in h and k straight from our center, and put in 4 squared, our radius squared. And that's going to give us x minus 1 squared plus y minus 7 squared equals 16. That is the equation of our circle. And we should be able to look at that and say immediately, A, that's a circle. B, it's got a center of 1, 7. And C, its radius is the square root of 16, or 4. Okay? So that, just from looking at that, we have all of that information just by looking at this one equation. So here we're going to have to find the center and the radius and then graph it, okay? So we'll complete the square twice. We'll complete the square on the x's and we'll complete the square on the y's. And we'll make sure that we add just both of the constants over to the other side. So you can look through and see where these constants of 1 and 9 came from. Make sure you understand that, and make sure you understand how we got x plus 1 squared and y minus 3 squared. Again, it's a reiteration of completing the square. So pause the video and look through it and make sure you get the same. Okay? Negative 6 plus 1 plus 9 equals 4. So what's our radius? It's 2. It's the square root of 4. So our center is negative 1, negative 1, positive 3, and our radius is 2. So our center is negative 1, positive 3, and then we go 2 units out. And it's best to just hit the 4 kind of, they're not corners, but the 4 that you can actually get the exact radius out from. And this just kind of connects it into a circle from there. As you could guess, mine always look bad because I'm not a good drawer.